All right, balancing chemical equations is actually a pretty straightforward, easy process. Just have to think of the yield arrow in a chemical equation as an equal sign. So everything on the left of the arrow has to equal everything on the right of the arrow. In this example, it's magnesium plus sodium nitrate makes magnesium nitrate and sodium. You have to make sure your formulas are written correctly. And if you look at this, on the right-hand side, you have two nitrates. On the left-hand side, only one nitrate. This is why we need to balance. You can't have magically produced an extra nitrate. And there's just a couple of rules, and they're not really rules. You don't even really have to follow them. You just have to make things equal. You don't have to follow this, but the easiest thing to do was to look for polyatomic ions, sulfate, sulfite, phosphite, and in this case, nitrate. If you have polyatomic ions in the equation that are unchanged, in this case, it's nitrate on the left, and it's still nitrate on the right. You want to do those first, and you want to keep them together. You don't want to break it into an N and an O. You want to balance the NO3 together. So if we look at this, we have one nitrate on the left, but we end up with two nitrates. And we can't have created an extra nitrate. So if we ended with two, we must have started with two. And as far as on a particle level, that means we simply have another sodium nitrate. We can't change the formula of sodium nitrate, but we can have more than one. Okay, and now the second rule is to just do everything else one at a time. We have one magnesium on the left. If we go over to the right, we have one magnesium. So the magnesiums are done. Two sodiums on the left, but only one sodium on the right. Well, if you started with two, you had to end with two. So we'll just put a 2 in front of the sodium, draw our extra particle, and we'll keep going. So the magnesium's done, the sodium's done, our nitrates are work out 2 on each side, so this is now balanced. One magnesium, 2 sodium nitrates makes one magnesium nitrate and 2 sodiums. Do another example here. This is methane plus oxygen produces carbon dioxide and water. It's just a general combustion reaction. The first rule is look for polyatomics. There are none in this case, so we'll just balance them one at a time. It's easiest just to start on the left and move to the right. So carbon is first. We have one carbon on the left, one carbon on the right, so the carbon is done. We have 4 hydrogens on the left, but only 2 on the right. So if we started with 4, we have to end with 4. That means we need 2 water molecules. And now we'll move on to the oxygen. We have 2 oxygens on the left, and on the right, you see the carbon dioxide has 2, and we have 2 waters, which gives us 2 more oxygens, so a total of 4 oxygens on the right-hand side of the arrow. So if I ended with 4, I had to have started with 4, so I'll put a 2 in front of my O2. And this is all balanced now. One more little example. This is a decomposition. It has only one reactant, so it looks kind of different, but it really isn't. You're just going to take it one at a time and balance them. There are no polyatomics to worry about, so we'll just do it one at a time. Start with the aluminum. We have 2 aluminums on the left-hand side, but only 1 on the right, so we'll make it 2. Go back over to the left. We have 3 oxygens on the left and 2 on the right. So we have an odd number on the left-hand side of the reaction and an even number on the right-hand side. You have to find the lowest common multiplier, and 2 times 3 is 6, so we'll make it 6 oxygens on both sides. If we put a 2 in front of aluminum oxide, that gives us 6 oxygens on the left. We put a 3 in front of the O2, that gives us 6 oxygens on the right. So the oxygen is now done, but we have caused a problem with our aluminum. We now have 4 aluminums on the left. Well, we just simply need to change this and make it 4 on the right. And that's all there is to balancing.